So in this lesson we are going to look at Pythagoras' theorem. Pythagoras' theorem, it only relates to right angle triangles. So that is a triangle that has, for example, one 90-degree angle that makes up the three angles that make up the triangle. So Pythagoras' theorem basically can be used to, if you have the length of two sides of a triangle, you can use Pythagoras' theorem to work out what the other lengths are. And it's found in your logbook table, so you don't need to memorize this, but you do need to know how to use it. So if we take Pythagoras' theorem, what it says is that a squared is equal to b squared plus c squared. Okay, so what that means is that the longest side, which is a squared, so if we have a look at this Pythagoras, at this right angle triangle here, this would be a, okay, and then this would be b, and this would be c. So what it's saying is that the length of the longest side squared is equal to the sum of the other two lengths. So it's the sum of this length squared and the sum of this length squared. Now, another way that I like to look at this as well is that we can use these other words to represent each of the sides. So for example, the longest side, we can call it the hypotenuse. Okay, and I'll just represent it with a h. Okay, and we can call this the opposite, and I can represent it with an O. Okay. And then we can call this the adjacent. Okay, so the adjacent, like so. And again, this formula then will translate into h squared is equal to O squared plus a squared. Okay, so it'll look something like that. So let's look at a type of problem that you could be asked in relation to this. So generally, when you're answering questions that relates to the theorem of Pythagoras, they'll give you something like this. So they'll give you it'll be relating to a right angle triangle, and they might give you the length of the triangle. So for example, this length here could be 12, and let's say this length here could be 10, and they might call this length here x. Okay, and they'll ask you to work out what x is. So let me just get rid of some of these here. Okay, so they might say to you, work out what the length is of this side of the triangle, which is known as the hypotenuse. Remember, the longest length is called the hypotenuse. So in order for me to work out what this is, I can use Pythagoras' theorem. So for example, we can write it like this. So a squared is going to be this length here squared, which is going to be, if we call it, we'll just call it, we don't know what that length is, so we'll call it x squared, is equal to this length here, 10 squared, plus this length here, which is 12 squared. Okay, so it looks something like that. So what we're trying to do is we're trying to find the length from here all the way down to here. So again, we use Pythagoras' theorem, which is this formula here, so we can use either of these. And then what we do is we just plug in the values that we have, and we can start to solve it then. So what we can say then is that x squared is equal to 10 squared plus 12 squared. So if we work out what these are then, so x squared is equal to 10 squared is equal to 100 plus 12 squared is equal to 144. Okay, so it looks something like that. And then if we add these together, so x squared is equal to 244. Now, what we want to do is x squared, we're trying to find out what x is. We're trying to find out what the length is. So what we have here is x squared. So we want to get rid of this power up here. So in order to get rid of the power, I have to do the opposite of what a power is, and that's I have to square it. So I get the square root of this side, and whatever I do on one side, because we have an equal sign here, I have to do the same on the other side as well. So that gets rid of the power, and it leaves us with x is equal to the square root of 244, which is equal to 15.62. 15.62. So what that tells us that if we have a right angle triangle, and this length is 10 and this length is 12, then the longest side, or the hypotenuse, is going to be equal to 15.62. And we've used these guys here. Okay, so we've used Pythagoras' theorem in order to solve this. So again, remember, Pythagoras' theorem only relates to right-angled triangles, and it's basically like a pattern that holds true in relation to right-angled triangles. The longest side squared is always going to be equal to the sum of the other two sides squared. And that's what's represented in this triangle. And we can use that then, in order to work out one of the sides, we have to have the other two sides, and then we can use the formula, Pythagoras' theorem here, and we can work out the unknown length of the side. Okay, so let's look at some other examples. So let's get rid of these. And let's say if we have something like this. Okay, so we have x. Let's say we don't know the length of this side, but we have these other two sides. So we have 14, and let's say this side down here is 12. So again, we want to, like, first of all, label the parts and see like what side is what. So the longest side is always h, or the hypotenuse. So we call this h. Okay, we can call this here the opposite. Okay, this side here, and we can call this side the adjacent. Okay, so the adjacent. So once we have all of those parts, what we can do then is we can use this formula here. So h squared is equal to o squared plus a squared. So let's work through this one. Let me just get rid of what we have here. Let me start again. Okay, so it's going to look something. So again, h squared. So h is equal to 14 in this case. So 14 squared is going to be equal to the opposite, which is what we're trying to find. It's the unknown. So we'll just call it's called x squared plus a squared, which is 12. So 12 squared. So it looks something like that. So now what you want to do is you want to get rid of these squares by squaring it. So if we take 14 squared, that's going to be 196, is equal to x squared plus, if we take 12 squared, that's equal to 144. Okay, so now what we want to do is we want to get this x squared on its own, so we have to get rid of the plus 144 over here. So again, this is plus 144, so to get rid of it, we have to minus 144. And then if we take away 144 on the right, we have to take minus 144 on the left then as well. So these two will cancel out, and we'll be left with x squared is equal to, so 196 minus 144, so is equal to 52. And remember, in order to get rid of this power here, we have to do the opposite of a power, which is a square root. So we square it, we square this side, and then x is going to be equal to the square root of 52. So x is going to be equal to 7.2. Okay, so again, we have this side here is 14, this side here is 12, and we've just worked out that this side here is 7.2. Okay, so again, we're using Pythagoras' theorem to work out the length of one of the sides. And again, in order to use Pythagoras' theorem, it has to be a right-angled triangle, and you have to have two of the three sides of the triangle. Okay, so let's look at one more. So let me get rid of this. And let me get rid of these here. So let's try this one. So let's say if we have, let's say this is, let's say the unknown is here. So this is x. So this is 5, and then this is 10. Let's say. So again, the first thing we do is we identify the sides. Okay, so this is h, or we can call it a. So this is h, this is o, and then this is a. Okay, so now we were able to use this formula. So we take the values from the triangle and we plug them into this formula. So we have 10 squared is equal to o squared, which is 5 squared, plus x squared, and x is what we're trying to work out. So 10 to the power of 2 is equal to 100, is equal to 5 fives is 25, plus x squared. And then what we want to do is we want to get x squared on its own, so we have to get rid of this 25, so we have to minus 25. If we minus 25 from one side, we have to minus 25 from the other. So these will cancel out, and you'll be left with x squared is equal to 75. And then in order to work out, to get rid of this square here, I have to get the square root of it. So I get the square root of both sides, and x then is equal to the square root of 75, which is equal to 8.66. Okay, so this length here is equal to 8.66. So that is Pythagoras' theorem, and that's how to use Pythagoras' theorem to work out the length of one side if you already have the length of two of the other sides. And just to introduce this concept just for the next part, when we start to look at some further calculations using Pythagoras' theorem. So again, I mentioned that, so again, we can use this formula here, which is just the longest side is equal to the sum of the squares on the other two sides. Or we can use this one, as we're saying, which is the same thing as this. So the hypotenuse squared is equal to the opposite squared plus the adjacent. So the hypotenuse is always the longer side. The adjacent and the opposite, okay, like sometimes the bottom part here can be the opposite, and sometimes this side can be the opposite, or the adjacent can be this side, or sometimes this side as well. So what determines whether it's the opposite or adjacent is when we start to look at angles. So if we have an angle in here, for example, if we have an angle in this corner, then this here will be the opposite, so it's opposite to the angle. Whereas if we're looking at the angle up here, let's say, then this down here will be the opposite. It'll be opposite the angle that we're interested in. And that's going to become more relevant, let's say, in the next section. But for the purpose of when you're working with this particular formula, working with Pythagoras' theorem to solve these kind of questions, it doesn't matter. As long as you identify the longest part here as a hypotenuse, if you say this or this is the opposite or the adjacent, it doesn't matter. So, but it will matter for the next type of questions that we're going to look at. So it's just important that you know and you're familiar with each of these pieces, as in, so that you know that the longest side is always the hypotenuse, and then you have the opposite and the adjacent to either side. Okay, so thank you for listening.